The Rock Shifter 2000 replaces the need for hand sifting and hand picking dangerous rocks out of small crop fields. The Rock Shifter is a wheelable rock shifting system that is loaded with small loads of rock-filled soil, costing only $50 to produce. The frame is 30 centimeters by 30 centimeters by 40 centimeters, and it is made out of wood. This frame sits on 4 durable wheels, allowing you to access the rough terrain of the fields. The shifter can then process around 1 kilometer squared per hour. Within this frame are 3 graded metal trays that act as the filter for the loaded soil. Each level has different sized holes to catch different sized rocks. The machine will filter rocks at an 80% success rate. In the front of the frame, there are 3 slits in the wood, so the filters trays can be pulled out and emptied of the rock. The 3 trays are able to hold 25 kilograms of rock. The frame is open at the top and the bottom. The top opening is where the machine is loaded by shovel with the soil, and the bottom opening is where the filtered dirt drops back to the field. On the right side of the box frame is a wood crank. The crank can be turned to apply force to a gear system that activates the agitator. This agitator provides the energy needed to shake the rocks free from the soil.
Since each of the components that make up the Rock Shifter 2000 are essential to the end goal of separating rocks, each part plays a different and specific role in rock sifting. The Rock Shifter 2000 is made up of 5 sub-assemblies, in which each completes a more general task than the parts that said sub-assembly is composed of. The Rock Shifter 2000 is made up of sub-assemblies to organize each task that it completes in order to achieve its main goal of separating rocks from soil. Additionally, the product can be built more efficiently by assigning one worker to build a single sub-assembly, which reduces the chance of confusion regarding individual parts and speeds up the building time if there is more than one worker. Furthermore, if a defect occurs or a part of the machine breaks, it is easier to diagnose the problem in steps, by first identifying the subassembly that is causing the issue, then which part in this subassembly is defect or broken. Overall, by having one worker per subassembly, the building time for the machine is cut to just 20% of the original building time, allowing for more efficient production time as well as less chance of part confusion and error. The main problem that would like to be avoided is part fatigue, and since changing the material to something stronger would only raise the weight and cost of the product, subassemblies are a very good solution to this problem, as they allow for quick and easy diagnosis and replacement of parts that will tend to wear out the quickest. For example, since the machine will be rapidly vibrating for most of its life, parts such as gears will be under cyclic load, which will put more stress over time on these gears. By having a subassembly specifically for these gears, the user will be able to easily replace the entire subassembly, allowing for a quicker and easier repair time because the user will not have to deal with splining the new gears on and making sure that they are aligned properly, etc.
To assemble this product, we will first assemble subassembly 2 or SA002. The 4 parts for the back agitator subassembly are shown above. Start by gluing part 2 to part 1 with tight bond glue. Next, glue part 3 to part 1 with tight bond glue. Finally, align the combined product of part 1, part 2, and part 3 onto part 4, the back panel. Completing this will form the finished product of SA002. The next subassembly is the drawer, or SA003. The tool needed for this assembly is only a Phillips head screwdriver, but if you have an electric screwdriver, that would be more efficient. Start by screwing part 1, there should be 2 of these, to part 2. Next, screw part 3 to part 4. Finally, screw the combined parts of part 3 and part 4 to part 1. Again, there are 2 of these. Note, make sure the combined assembly is square. This assembly will be manufactured 3 times. The next subassembly is called the gear reduction, or SA005. The tools that are needed are Phillips head screwdriver and tight bond glue. There are 6 parts for the gear reduction. They are shown above. First, screw part 7 to part 2. Then on the opposite side, secure parts 1 and 3 to parts 4 and 5 with tight bond glue. Make sure that this is flush for a good rotation. The last subassembly are the wheels, or SA006. The tool needed for this subassembly is a Phillips head screwdriver. There are 5 parts needed for this subassembly, which are shown above. First, screw part 3 to part 4. There are 2 of these, but make sure that they are centric. Next, place part 1 into the slots of both part 2s. Finally, screw part 5 to the outside of part 4. This step must be secure, but allow the wheel to freely rotate. This process will be done twice for both sets of wheels.
Once you have completed building each subassembly, you can move on to putting together the final product. First, secure the side panel to the front plate using wood screws. Next, screw the back agitator to the side panel, followed by screwing the gear reduction to both the back agitator and the front plate. After that's completed, slot each drawer into place through the front plate. Finally, these wheels can be screwed to the bottom of the frame using wood screws.